Now we're being asked to find out the Marshallian demand functions for u equals to x1 plus root x2. Remember this, that this is the form of quasi-linear utility function. Okay, this is a form of quasi-linear utility function u equals to x1 plus root x2. That is, one is a linear function and other is a non-linear function. Linear because its degree is 1 and non-linear because its degree is not 1. Okay, so that is a non-linear function. This is a characteristic of a quasi-linear function. And your price vector, suppose if it is p1 p2, income of the consumer is m. So what is your budget line? P1 x1 plus P2 x2 equals to M. So this is your total expenditure and M is the income of this consumer. So it's being assumed is that consumer spend all his income on x1 and x2. Okay, and he is consuming on the budget line. He is not within the budget line, and hence this budget equation is of course holding with equality. Okay, now let's form the Lagrange. Okay, so you have how do you find out the optimum for this? You find out an optimum for this by using the Lagrange multiplier. So it is x1 plus root of x2. You want to maximize this utility subject to a budget constraint. So it is m minus p1 x1 minus p2 x2. Okay, now we'll be finding up three partial derivatives, that is del L by del x1, del L by del x1, del L by del x2, del L by del x3. Sorry, lambda. Okay, I'm sorry. So del L by del x1 would be 1 minus lambda p1 is equal to 0. Del L by del x2 would be 1 upon 2 root x2 minus lambda p2 is equal to 0. Del L by del lambda would of course be m minus p1 x1 minus p2 x2 equals to 0. Let's name these as 1, 2, 3. Okay. Now if you divide equation 1 by 2, okay, so what is it that you will be getting with? 1 upon 2 root x2 is equal to p1 by p2. Okay, so there will be 2 root x2 is equal to p1 by p2. Okay, so just squaring both the sides, you'll be getting 4x2 is equal to p1 by p2 square. Okay, and of course your x2 would be equal to 1 by 4 p1 by p2 square. Fine. So this is your demand for x2. Okay, so this is your demand for x2. Now the thing is that how will you find out the demand for x1? You will be remember this, that in this case, though Marshallian demand functions are in terms of income and prices, in this case it is not dependent upon income. Okay, so it is of course dependent upon prices, and this is your equilibrium or Marshallian demand function for x2, which is 1 by 4 p1 by p2 square. Okay, now let's put this into our third constraint. So it is m minus, we need to find out the demand function for x1. We'll just substitute it. So this will be p2 into 1 by 4 p1 square it should be p2, I'm sorry, this is p2, yeah, into p2 square is equal to 0. Okay, so 1 p2 will get cancelled out here and you will be left with m minus p1 x1 minus p1 square upon 4p2, okay, is equal to 0. Just just let's simplify this, and you'll be getting 4p2m minus 4 p1 p2 x1 minus p1 square is equal to 0. Clear? So let's write in terms of x1 only. We'll be getting 4p2m minus p1 square is equal to 4 p1 p2 x1. So your x1 would be equal to 4 p2m minus p1 square upon 4 p1 p2. Okay, so let's divide this by in terms of can we more simplify this? I mean, let's guess. I think we can. So what we'll do is that take 4p2 common from numerator denominator. We'll be left with upon 4p2 upon p1. Okay, so this is your x1. Now there is something peculiar about this expression, and this is the Marshall demand function for x1, which is in terms of income and prices. Okay, now what is peculiar about this expression is that what will happen in case if m is less than this expression. Okay, in case if your m is less than this expression, then the demand for x1 is 0. You can't have a negative x1, of course. Okay, so if now all this will go in case if m is greater than p1 square upon 4p2. Okay, everything is fine. Then this is x1 and this is x2, which you have to write. But in case if m is less than p1 square by 4p2, then in that case your x1 would be equal to 0 because it will come out to be negative. And in case if x1 is 0, then you will substitute this x1 into this budget equation, and that will be p1 into 0 plus p2 x2 equals to m, and hence x2 will come out to be equal to m by p2. So your entire income is going to be spent on x2. Okay, so this is what we have derived. Remember this point. This is a very important point. So if income is greater than p1 square by 4 p1 p2, then the demand for x1 will come out to be positive, and hence it is a valid argument. But in case if income is less than p1 square by 4 p1 p2, then in that case demand for x1 will come out to be negative, and hence we'll assume that this is equal to 0, and nothing is going to be spent on x1, and everything is going to be spent on x2. So you'll substitute that into the budget equation, and you will be having p1 0 plus p2 x2 equals to m. So x2 will be equal to m by p2. Clear?